You're listening to the Drive Forward podcast. We're cruising through the latest in transportation to inspire a better tomorrow.
Welcome to the 10th episode of the Drive Forward podcast. I'm your host, Emily Jankowski. Today, we're chatting with David Pittman, the director of the U.S. Army Corps of Engineers Engineer Research and Development Center. Well, welcome to the podcast, David. We're really excited to have you here. Let's go ahead and dive on in. Why don't you start off by telling me a little bit about your role as the director of the Engineer Research and Development Center for the U.S. Army Corps of Engineers? Yes,
well hello, Emily, and I appreciate the opportunity to join you today. So as you said, I am the director of the Engineer Research and Development Center. We call it ERDIC, just to make that shorter. That's actually headquartered in Vicksburg, Mississippi. So if you can detect a Mississippi accent here, that's authentic. That's where I'm from, actually, is Vicksburg, Mississippi. But we actually have over 2,000 people, about 2,500 to be exact, in 7 labs in 4 states. And one of those labs actually is right there in Champaign, Illinois. It's called our Construction Engineering Research Lab. It was actually born from the University of Illinois, so we have a very, very tight connection over decades with the University of Illinois. But the labs, the ERDIC, we're basically the research labs for the Army Corps of Engineers. So that's about 35,000 people strong. It's a worldwide mission. And we trace our beginnings all the way back to 1775, before the beginning of this country even. And we actually helped build this country. And today, the Corps of Engineers has a mission there's a military mission, so we support military installations. We actually have a warfighting function. And then we have this thing called a civil works mission, which is actually helping to build and maintain and operate our water resources, our rivers, basically, our dams, our levees. And then we have a disaster response mission. And after hurricanes and earthquakes and things like that, we support FEMA and other agencies. And then we do a lot of support for other agencies, again, like FEMA and the Veterans Administration. So it's a very broad worldwide mission. And the ERDIC, does research to support that. We say we discover, develop, and deliver new ways to make the world safer and better every day. It's a great place to work and a great job to have.
That's awesome. That's great to hear that it's been around for so long. I wasn't aware of how long that's been around. So definitely since before the development of our country, for sure. Well, we've chatted a little bit about the future of smart infrastructure on this podcast, from roadways talking to cars to 5G technology, keeping us all connected. But what about smart runways? I know this is something the University of Illinois Urbana-Champaign and the Engineer Research and Development Center are partnering together to explore. Can you share a little bit about this joint venture and the exciting possibilities?
Oh, absolutely. And it is very exciting. So, so smart infrastructure just at large is here. The whole nation, the world is really getting on board. And we spend trillions of dollars every year to design, construct, operate, and maintain all of our infrastructure from a federal level down to a local level. So today, we're combining smart technology like sensors, computers, new materials, new designs, autonomous systems, and building that into our technology and adding it on to existing technology, all to save time, save money, build in resilience and sustainability, and make it safer and more reliable. So ERDIC is in the game, of course, and the University of Illinois is in the game, and we're all partnering with the Air Force on the Smart Runway project. A lot of industry partners actually with Dynatest North America, a company called HHI Incorporated, Granite Construction, and Woolpert Incorporated. And then, of course, academia, University of Illinois and the University of Nevada at Reno. And so the specific project involves installing advanced sensors in a runway at Hill Air Force Base in Utah. That's a $100 million partnership altogether in looking at this smart runway. So there's a lot of money here. But what we're trying to do is understand the health and condition of the pavement over time. So by putting these advanced sensors into the runway, we can collect load response data when we're putting the aircraft loads onto the pavement to better understand the aircraft pavement interaction. So how does the pavement actually perform under the loads? And we're all doing this ultimately to improve the Department of Defense's pavement design procedure, which is used worldwide across all of our pavements that we have. And we're one of the biggest owners of pavements in the world, to reduce conservatism in design. So we tend to be a little conservative in the design. We make them thicker than they have to be, in other words. just because we don't understand all the things it takes to make them perform better. So the specific project then involved putting 84 sensors into that Hill Air Force Base runway. Those are earth pressure cells, moisture temperature gauges, multi-depth deflectometers, asphalt strain gauges, you name it, the sensors in there. And it's in all the layers, from the subgrade, the original ground, to the sub-base, to the base, and even in the asphalt concrete layer, the surface layer itself. And so we're going to measure critical pavement responses under loading, like how much does it deflect, how much of the pavement layer is strained, and then we'll check and calibrate the sensors over time to make sure they're giving us, really good quality data. Now we're also doing materials characterization tests, so we're, doing the test on the materials themselves to see how they're going to perform and respond. And those tests are done at URDIC and University of Illinois and UNLV. And then we're going back and doing non-destructive testing. A lot of that technology was developed at University of Illinois and URDIC in the past. So that looks at your pavement layer stiffnesses, how strong is it against a load? And you can do something called back calculating pavement layer parameters. And so we'll collect this data during loading. Actually, we'll put real loads on the pavement. We're going to do web-based data management because we're going to get, billions of terabytes of data over time, and we got to manage that data. And over time, we'll monitor the health of the pavement. And again, ultimately, we hope to improve our understanding of pavements themselves, reduce conservatism in design, and ultimately improve the reliability of our pavement systems. So that's just a major effort, and appreciate very much the partnership with the University of Illinois on it.
Wonderful. Isn't it amazing what we can do with sensors today, right? Well, speaking of runways, we all know the wear and tear these airfields endure. Providing a reliant path for heavy military aircraft to land, I imagine, is a much more unique situation than that of our typical commercial airline runways. How is the Engineer Research and Development Center thinking outside of the box to tackle these problems for the U.S. Department of Defense?
Well, you're right. I mean, the airfield pavement design procedure that we use today on all the Department of Defense airfields, that's Army, Navy, Air Force, obviously. That basic research and engineering was done, right after World War II. So it's decades old now, and it's the world's best model. I mean, it's derivatives of it are even used for civilian runways by the FAA, for instance. And so, and we all partner together. It's kind of a small world, but we're ready to kind of go to the next level and take advantage of the latest in data analytics and finite element design. And so we're partnering now with the leaders in the services. So the Air Force Civil Engineering Center, the Naval Facilities Engineering Command, the Corps of Engineers Transportation Systems Center of Excellence, that's in Omaha, Nebraska, along with the University of Illinois and University of Cincinnati, to come up with a new mechanistic pavement design tool for the Department of Defense called JEDI 2D. So that stands for the Joint Evaluation and Design Integrated Software. So this has been, a concept's been working for a while in this area, and now we're going to bring it to reality. So as I said, it's kind of based upon a legacy DoD pavement design system that originated all the way back to World War II. And it's very robust. It's got a lot of data behind it. A lot of it's empirical. A lot of it's mechanistic as well. We're actually using, physics-based procedures to understand the stresses and strains and deflections from loads and other loads that put on the pavement systems. But this will take advantage of 2D finite element modeling and then leverage other advancements that have come out of academia, industry, and other government agencies. So there'll be two major key components of the JEDI 2D system. You have two different classes of pavements, basically. You got rigid pavements, which is like concrete pavements. So that's a C-slab system developed by Tasos Ioannidis, who formerly from the University of Illinois, by the way, and then University of Cincinnati, and now working with us at URDIC. And then one for flexible pavements, that's your asphalt pavements, essentially, called C-Flex. And these DoD pavement response models will basically understand how the pavements will perform under a variety of loading conditions. And ultimately, we hope to have a new desktop-based pavement design and evaluation system called Pavement JEDI 2D.
Well, that's fantastic. It certainly sounds like really interesting concepts that are going to come out of those research studies and efforts together, for sure. Well, I know the future promises exciting technology like autonomous vehicles. Here at Illinois Center for Transportation, we have our sights set on building an autonomous and connected vehicle track known as the Illinois Autonomous and Connected Track in Rantoul, Illinois. How do you see the U.S. Army Corps of Engineers working with ICT on autonomous and connected vehicles, as well as drones, possibly to enhance military vehicles?
You're right. That is a fantastic facility. I actually visited it a couple of years ago at Rantoul, just north of Champaign, Illinois. And our construction engineering research lab, or CERL, is thinking about expanding in that area as well. But you already have a location there. And I saw the vision for it a couple of years ago. And it's an absolutely amazing, fantastic state-of-the-art capability. And while we have partnered together for decades on pavement research, this is going to take it to the next level. And we look forward to partnering with the University of Illinois on this new facility. But some of the areas that we've done research with autonomous vehicle research, we're a leader in this area actually for ground vehicles, airborne vehicles, and even waterborne autonomous vehicles. For instance, we're partnering with a company called US Ignite on something called a smart transportation test bed. It's being demonstrated at Fort Carson, which is in Colorado, and then the city of Colorado Springs and the University of Colorado to come up with an autonomous vehicle pilot program. That's a $4 million joint effort where we're going to try to reduce transportation costs, improve safety, and deliver faster services. We also do a lot of high-end modeling and simulation, physics-based modeling and simulation using our high-performance computing modernization program. We actually have supercomputers at one of our labs in Vicksburg, and we have a modeling simulation tool called Create for ground vehicles. So it's used to design autonomous systems for the United States Army, for instance, and the Marines. We also are leading a program for the future of Army engineer equipment. That's based out of our lab in Champaign called CERL. It's called Robotics for Engineer Operations. So we're actually developing the future of engineer equipment. And of course, we're doing a whole lot of research with UAVs at ERDIC as well, really helping set the standard for the Corps of Engineers. So a lot of things going on in ERDIC, some fantastic futures at Illinois' Autonomous and Connected Track at Rantoul, and we look forward to working with you on that new system.
That's wonderful. Well, one more question for you, David. What legacy do you hope to leave at the U.S. Army Engineer Research and Development Center?
Well, I hope, as any leader would have, I would think, just the biggest legacy would be to help other leaders grow and develop to carry out the great mission of the ERDIC. ERDIC itself has been around for 91 years. We started in 1929, and we have many, many more years to go. And so what I hope is that I've been able to help a little bit other leaders grow and leaders from top to bottom, secretaries, technicians, engineers, and scientists, to carry on that great mission of the Corps, because our strength is and always has been our people, and it always will be. So if I have any legacy, I hope that's what it is.
Well, that's all I had for today, David. I hope I speak on behalf of all of us in saying we so appreciate what you and the U.S. Army Corps of Engineers do. Thank you so much for your willingness to join us on the podcast. And listeners, thanks for staying tuned in.
The Drive Forward podcast is a production of Illinois Center for Transportation, a research center of the University of Illinois at Urbana-Champaign. We invite you to subscribe to the Drive Forward podcast on iTunes, SoundCloud, or Spotify. And while you're there, feel free to like or rate us. Thanks for listening. Keep the conversation rolling by using the hashtag Drive Forward.